Intermediate Algebra for Statistics, solving radical or square root equations. Lesson objective: solve a radical equation in one variable. Lesson objective: examples. Examples of rational equations in one variable look like this. Square root of x equals 5. Cube root of 7x minus 3 equals 2. Square root of x minus 2 equals x minus 4. And square root of x plus 3 minus the square root of 2x minus 4 equals 6. Property: if a and b are expressions, then all the solutions of the equation a equals b are among the solutions of the equation a squared equals b squared. That is, the solutions of an equation are among the solutions of the equation obtained by squaring both sides. This is how we will eliminate the square root, is we will square. Property: extraneous solutions. Let's take the equation x equals 5. If I square both sides, I get x squared equals 5 squared, or x squared equals 25. Now if you have an equation x squared equals 25 and you solve for x, you take the square root of both sides. We did these types of equations when we talked about quadratic equations. So we would say x equals plus or minus the square root of 25, which means x is equal to plus or minus 5. But there's a problem, and this has two solutions, and we really only started with one. So we introduced negative 5 as a solution that really is not a solution. And this is an example of an extraneous solution, because squaring both sides of a square root equation may introduce extraneous solutions. It is essential to check that each proposed solution satisfies the original equation. Let's do an example. Example 1. Solve the equation 2 times the square root of x plus 5 equals 13. We want to get the x by itself. We need to get rid of the square root. We need to get rid of the 2. We need to get rid of the 5. So we want to follow the order of operation in reverse. So our first step is to subtract 5 to both sides. We now get 2 times the square root of x equals 8. The next thing that we want to undo is the 2. So the inverse of multiplying by 2 is to divide by 2. So we have square root of x equals 4. To undo the square root, we square. So we square both sides, and we get x is 16. Now we need to check it. So we take the original equation, we substitute 16 in for x. The left-hand side should equal 13, what's on the right-hand side, if this is really a solution. Now, we follow the order of operation, so we first do the square root, then we multiply, then we add, which is again in reverse order of solving. Square root of 16 is 4, 2 times 4 is 8, and 8 plus 5 is 13. It checks. Example 2. Solve x equals the square root of x minus 1 plus 3. Solution: we start with the original equation. Our first step is to isolate the radical. So I need to get rid of the plus 3. So I subtract 3 to both sides, and I have x minus 3 equals square root of x minus 1. Now to undo the square root, I square both sides. X minus 3 squared means x minus 3 times x minus 3. So you'd have to FOIL this out. Or if you recall, we can square the first, double the product, and square the last. On this side of the equal sign, the square and the square root cancel, and we're left with x minus 1. So we have the equation x squared minus 6x plus 9 equals x minus 1. Next, we want to subtract x to both sides and add 1 to both sides, where we have this quadratic equal to 0. We can factor this, what two numbers multiply to give me a positive 10, and at the same time add up to give me a negative 7. Or we can apply the quadratic formula. I'm going to factor it. Negative 2 times negative 5 is positive 10. Negative 2 plus negative 5 is a negative 7. Setting both these binomials equal to 0, we have x is equal to 2 or x is equal to 5. So we have two solutions. We must check both of them to make sure they both work. So for x equals 2, you start with the original equation. Hopefully the left-hand side will equal the right-hand side. Substituting 2 in for x, we have 2 equals the square root of 2 minus 1 plus 3. Following the order of operations, we have to subtract, then we take the square root, then we add for the right-hand side, and we get square root of 1, which is 1, plus 3, which is 4. So the left-hand side and the right-hand side do not equal. This is a false statement. Therefore, 2 is not a solution. To check x equals 5, we substitute 5 in for x. Right-hand side, 5 minus 1 is 4. Square root of 4 is 2. And 2 plus 3 is 5. This is a true statement. 5 is a solution. We can verify this graphically by putting x and y1, that's the left-hand side of the equal sign, and the square root of x minus 1 plus 3 and y2 for the right-hand side of the equation. Hit graph and use our intersection feature, and we can see there's one point of intersection when x equals 5. Example 3. Solve 2 times the square root of x minus 3 minus the square root of x equals 0. Solution. Our first step is again to isolate the radical. So if we add square root of x to both sides, we have 2 times the square root of x minus 3 equals the square root of x. Next, we want to square both sides of the equation. Square root of x squared, the square root and the square cancel. Now we have to be careful here because we have a 2 that's being squared also. So this will become 2 squared. So this will be 2 squared times x minus 3. Using the distributive property, we have 4x minus 12 equals x. Next, we want to subtract x to both sides and then add 12 to both sides. We get 3x equals 12 or x equals 4. To check it, I'm going to use the graphing calculator. I put the left-hand side of the equal sign in y1, and using the table feature, I type in 4, input, and the output 0. So 0 equals 0. It checks. Warning: it's very easy to forget to square the 2. This statement is not correct. These two quantities are not equal. You had to remember to square the number outside the radical. Thanks for watching.